In this video, we'll be looking at lesson 1.5. This will be our first lesson on factoring, where we will be factoring monomials, and we'll be factoring by grouping. My essential question will be, what is factoring? We'll have two essential questions. What is factoring? Maybe three essential questions. What is factoring? How do I factor out monomials? What is factoring? How do I factor out monomials? How do I factor by grouping? So factoring is the reverse of distributing. So when we distribute, we multiply something on the outside in. So when we're factoring, we'll try to divide something out. So we will divide out a term or terms. So the first thing we'll do is look at factoring out a monomial. The first one's pretty straightforward. 21b minus 15a. So our thought process needs to be, what is a number or variable that is common to both terms that I can divide out? So is there a number I could divide 21 and 15 by, or do they both share a variable? Well, when I look at 21 and maybe think of it as negative 15, they both have a factor of 3. I can divide them both by 3. So we can factor out a 3. And then when I'm factoring, I'm dividing. So this is all division. So once I factor that 3 out, I will now have a 7b minus 5a. And a lot of times when we factor, especially when we're dealing with these monomials, it's quick to check our work by just multiplying them back in. 3 times 7b would be 21b. 3 times negative 5a would be negative 15a. So that's kind of like the easiest kind of way is when we're just trying to factor out a number. So if you would, please try this one on your own. So pause right here and try this on your own. Okay, so if we tried this on your own, and when we look at this, we can see that they both have a 4 that we can divide them both by. So I'll factor the 4 out, and I'll have 4t minus 10y. Oop, looks like there's a larger number I could have factored out. So let's do the 8. They both have a factor of 8, so we always want to look for that larger number. So if I factor out 8, I would get 2t minus 5y. Now let's see what happens if we have some variables that are common to each term. So I have 14c squared plus 2c. Now when I look at this one, I can factor out a 2 from both. 14 divided by 2, 2 divided by 2. And they both have a c variable common. So I can factor out 1c from each of them. So c squared would become c, and that c kind of just factors out. I don't want to say disappears because it'll be moved out front. So what we have is 2c times, when I divide, I get 7. And then if I took 1c away from c squared, I'd c. Now think about this as division. If I'm doing 2c divided by 2c, I still have something left. So just because we factored out the whole 2c doesn't mean there's nothing there. It means we're going to have a 1, because this is division. So when I remove it, I'm doing 2c divided by 2c, which is 1. And that's how that one will work. And then we're done. So if you would, you can try this one on your own. So pause here and try this one on your own. So when we look at so hopefully you took the chance to try this on your own. So when we look at these two terms, they both can be divided by 2, and then they both share a k. The most amount of k's I can pull out is 1, 2 k's here and only 1 k here, so we'll do that. So I'll take out a 2 and a k, and then what's left behind, well, if I take the 2 out, there's no more coefficient, I remove 1 k, so I still have 1 k left behind. And I'm dividing 4k by 2k, so that becomes 2, and then the k divided by k kind of cancels that out, and there we go. Now let's try one similar to 3 and 4, but a little bit more complicated. Let's say I'm doing 10g squared h squared plus 9g squared h minus g h. So if we look at this one, I look at my coefficients, 10, 9, negative 1. So there's really no number that I can factor out. And I look at my variables and what's common to each. To be that at g squared. And if I look at my variables, what's common to each? Well, each one has a g squared, and each one has at least an h. So I can pull an h out of here, and h out of here. So that's what we'll be able to factor out, a g squared and one h. So we'll have our g squared. Each term has a g squared, and then I'll factor out just one h, and then whatever's left behind, we'll write. So I did nothing with the number out front, so it stays 10. And I took a g squared out and 1h, so I'm left with an h. Again, I did nothing to the number out front, so that stays the same. Factor out a g squared and an h, so I'll stay just 9. And then if I factored out a g squared and an h from this whole term, we still have 1 left behind. And then we'll want to clean it up by combining like terms. So we have g squared h times 10h plus 8. So that's how a little bit more complicated one looks, where we're just looking for that commonality between each term and then factoring that out. So if you would, you can go ahead and try this one on your own. So pause here and try this one on your own. Okay, so hopefully you took the chance to try this one on your own. When I look down the line, I see that I have a 4, a 2, and a negative 10. So all those are divisible by 2. So I can factor a 2 out. And then I see that I have an a squared, and an a. So each term has at least one a, so I'll pull that one of those a's out. And then I look down and I see I have a b squared, and a b, and each term has at least a b, so I'll pull a b out. And then we just divide as we go down. So 4 divided by 2 is 2. Those a's will cancel, and then b will leave one b behind. And then when I get down, I might bring my plus sign down. And then I have 2 divided by 2 is 1. We can write the 1, but we don't have to. I'm pulling 1a out, so 1a is left behind. And I have b squared here, so I have 2 b's, and I'm pulling 1 out, so I still have a b left behind. Then I'll subtract 5, and I've pulled both the a and the b out, so it stops right there. And that's our final answer. Okay, so that's how we can factor out a monomial. Let's go to factor by grouping. And this, and we'll use both of them when we're solving these equations. Currently, we're just working on like kind of a skill right now, and then later we'll use that skill to solve. So we'll use factoring monomials, and we'll use factoring by grouping. But factoring by grouping has a little bit more to it. So we're going to call this factor by grouping. And the example we'll be looking at is I'm going to put my steps over here on the left, and then the problem that kind of follows the steps over here on the right. So we'll put steps here, and then our example here. So first I want to give you the equation we'll be looking at. NP plus 2n plus 8p plus 16. So we'll be using that equation. So I'm going to go a little bit below that equation and put my first step. My first step will be split into two groups using parentheses. So what that means is I see 1, 2, 3, 4 terms, so I can put parentheses around 2 of the terms. So I'll have 2 groups. So the way that'll look is, if I just rewrite the problem, then I'll put parentheses around the first group, like so, and then I'll put parentheses around the second group, like so, leaving the plus sign in the middle of the 2 parenthesis groups. My next step is to factor out a common term from each group. So right here, if I'm looking at this first group, what's a term that's common to each um, from each term here? Well, this one has an n and this one has an n. So I can factor out an n, and then what I have left behind is p plus 2. And I'm going to do the same thing to this group. I can factor out an 8. And what do I have left behind? I have p plus 2. And notice that we have something that's exactly the same. And that's our goal, to get that same exact term or binomial following these, what we just factored out, because then I can kind of finish this problem up. So these have to be the exact same for me to be able to move forward. So my next step is to factor out the common binomial from each group. This is kind of like the last step. So when I look at that, I have my p plus 2, and I have my p plus 2. So I can take that and I can factor that out. So I'll have my p plus 2 right here. And then the n plus 8, then this n and this plus 8, they just kind of come straight down. So I have n plus 8. And if we want, or if you see it written in the, just switching this order, that's perfectly fine. We can have n plus 8 times p plus 2, and these are the same thing. Order doesn't matter. So this is how our problem started. And the first thing we did is put parentheses around the first two terms and around the second two terms, splitting it up into two groups. And then I looked at each group individually, factoring out a term. N was common, so I factored out the n. And 8 was common, so I factored out the 8. And then I was able to say, well, p plus 2 is common, so I can factor that binomial out. Boom, boom. And then I just brought what was left kind of straight down. Okay, so let's try some more examples. So I'm just going to follow my steps. First step is split into two groups using parentheses, like so, like so. And then my next step is to identify a term on what I can factor out from each group. This group I can factor out an x. And when I do so, I'm left with y minus 7. In this group, I can factor out a 7. And when I do that, I'm left with y minus 7. Factor out my 7, I'm left with y minus 7. Now, since they both have that y minus 7, I can factor that out, like so. And once I've factored that out, I'm left with the x and the plus 7, and I bring those down. So it's kind of like if we want to add this to our notes, you're this and this, and so the same, they're factoring out front like so. And then this n and this n plus 8 are coming down like so. Hopefully, if you added that to your notes, it doesn't make it too confusing. But that's kind of what we're doing. So if you would, please try this one on your own. Fg minus 5g plus 4f minus 20. So please pause right here and try this one on your own. Okay, so hopefully you took the chance to try this on your own. I'm just going to follow my steps, put parentheses around my groups. Okay. Now I'll factor out a g from that one. So if I factor out a g, I'm left with f minus 5. And then I can factor out a 4 from my second group, and if I do that, I'm left with that f minus 5. Exactly what I'm looking for, the same binomial for each term. And then now I can factor out the f minus 5 out front. And then I have my g plus 4 coming down, just like that. Now we need to talk about, real quick, a special case, and that's if there's subtraction in the middle, so different color. So change middle subtraction to plus a negative. And I'll just do one example so you can see this, and then hopefully the idea is there. So let's say I'm doing 3bc minus 2b minus 10 plus 15c. So we'll make this easiest is if we change this subtraction right here in the middle into plus a negative. So I'm just going to recopy the problem doing exactly that. 3bc minus 2b plus negative 10 plus 15c. So by doing that, now when I do my grouping, it should kind of alleviate any kind of like worry about things not looking exactly the same. And we get to keep our negative straight. This definitely helps us keep our negative straight. So we'll do our grouping, leaving that plus sign in the middle. So now what's common to these two terms? Well, they both can't divide out anything from the number. I can divide out the b, so I'll have b times 3c minus 2 plus, and over here I can divide 5 out from both, and I have negative 2 plus 3c. Now if we think about this, oh, did I not write the 5? There we go. Now if we think about this, this 3c minus 2 and this negative 2 plus 3c are the same thing. I have a positive 3c on both, and I have that minus 2 or negative 2 on both. So they really are the same thing. So that's the term I can factor out. When I factor out, though, I'm just going to write it like so, using the one where I have my variable come first, kind of in standard order. And then so I factored the 3c minus 2 out, and then what I have left over is my b plus 5. So just wanted to show you that special case in case you run into something like that. You'll have an example to help you get through that. Well, thank you very much for watching this video, and I hope you have a great rest of your day.